So we have drawn these anywhere in 8.4 notes. What does a proportion look like? If I want to figure out if these are proportional, what does a proportion look like? Yes, but I'm saying, like, what does a proportion equation look like? They just have an equal sign between them. That's what makes them, yeah, okay. Yeah, it's okay. So we're trying to see if they equal. You can reduce and see if the fractions equal if you're great at reducing. The second option is you can cross multiply and see if they equal. Because when you cross multiply, you're saying these two things equal. What's 6 times 24? 144. So we want to see if it is equal to 8 times 18, which is 144. So are these two proportional? Yes. You still would have figured it out if you reduced. That is also an option. I just like cross multiplication because especially like this one, 14 times 10 is 140. That's super easy. So you would just need to multiply 8 times 21, which is 168. So are they proportional? No. So in this section, we're going to have to see if ratios are proportional. So this is one method. You can reduce. This is another method. But we will pause to pray. So 8.4 is about proportionality theorems and the converse. The converse is the opposite. It's like saying if 1 plus 2 is 3, then what's 2 plus 1? That's 3. They're saying the same thing, just in reverse. So I'll show you that. It's super simple. So you see this at the top. It says, if a line parallel to one side of the triangle intersects two sides. So which two lines are parallel in this picture? Right, QS and TU. If they are parallel, then they divide the two sides proportionally. So the two sides would be this side and this side. They're divided proportionally. So here's what that will look like. We can take RT and put it over TQ. And these two sides will be proportional, so equal, to RU over US. Does everyone kind of see the pattern? So this is option 1. I have also seen people do the length of QT over the length of SU, and it would be equal to TR over UR. If everyone can kind of see the color coding. These are your two options. I usually do the first option, because usually the triangles are up and down, like in example 1, like sitting straight up rather than sitting sideways. But both will be correct. Is everyone okay with how to set it up? Okay, let's practice. So in the diagram, QS is parallel to UT. That's these two lines. The length of RS is 4. That's that one. The length of ST is 6. The length of QU is 9. What is the length of RQ? So what do we want to call RQ? We can call it X. So we know the sides are proportional. So we're going to set up a proportion. When it's up and down like this, I think it's really easy to set a proportion that looks like this. X over 9 equals 4 over 6. Similar is the first option I showed you, like up here. So here's what that would look like. We're going to take X and put it over 9. Put it over 9. And it will equal, what would go in the numerator? 4 over 6. And then you cross multiply. So we would have 6x equals, 9 times 4 is 36, so then x equals 6. That's it. When you're ready, we can turn the page and practice twice more. So again, we're going to find the length of AB. And actually, we should have called it AB at the end. That's my bad. Or RQ. Sorry, on that first one, we should say RQ. The length of RQ was, it was 6, right? Yeah. We made up the letter X, so just so you know. So same thing here. Our goal is to find the length of AB. So in the end, we'll have AB equals a number. But we can call it X for now. What number, pick any number here, that you would like to go first? It doesn't matter. Do you want to use X first? That's fine. So X over, there are 2 options to put in the denominator. We can use 6. And so then we will set it equal. What has to go in the numerator if X is in the numerator? 5 over 10. Cross multiply. We get 10x equals 6 times 5 is 30, so x equals 3. This one you could have also solved in your head. Because the scale factor will be the same on both sides. What's the scale factor to go from the length of 10 to the length of 5? It's times a half, right? 10 times a half gives you 5. So the same thing here. What is 6 times a half? 3. So you could have also used that method. Both are correct. But like on number 2 is not an option. Because looking at, you're given 2 and 9. Right off the top of your head, do you know 2 times what makes 9? Yeah, it's going to be a fraction. So we're going to set up a proportion. Man, I still circled x. We still want AB. The length of AB is 3 on that first one. All right, the second one we're still looking for AB. So what do we want in our first numerator? X, sounds good. And in the denominator? 7, sounds good. Equals 2 over 9. This is going to be a fraction answer, I believe. So we'll just leave it like a fraction at the end. Cross multiply, we get 9x. What is 7 times 2? 14. Divide by 9. Does 14 over 9 reduce at all? No, so we're going to leave it as 14 over 9. And again, we're not going to call it x, we're going to call it AB. That's the first section. So here we had 2 parallel lines, so the sides were proportional. In the next section, we're going to decide if the lines are parallel, and they'll be parallel if the sides are proportional. That makes sense? So we're going to be deciding if lines are parallel, and they will be parallel if the sides are proportional. We'll pop up here. So if a line divides 2 sides of a triangle proportionally, then it is parallel to the third side. So if this proportion happens, that means TU is parallel to QS, just in reverse here. So we're going to determine whether AB is parallel to XY. So we're going to see if the sides are proportional to each other. So we would say like 3 over 4. We want to see if it is proportional, if it is equal to 4 over 5. You could probably figure out that it's not. But you can cross multiply. 3 times 5 is 15. Is that equal to 4 times 4? No. So these are not parallel. There's no symbol for not parallel. Would you say not parallel? And then the last one, pick a number, any number. Which one? 5? What would we put in the denominator? We could put 4 in the denominator. If I put 5 over 4, what would go in the numerator of my second fraction? It'd have to be 7.5. These two came from the same side. So 7.5, and then 6 would be in the denominator because 4 and 6 came from the same side. I'll show you the way we have been doing it and show you how it's the same answer. But 5 times 6 is 30. And then what is 4 times 7.5? 30. So these are parallel. So we're going to write the statement AB is parallel to XY. It would have been the same answer had we done 7.5 over 5 equals 6 over 4, which is the way we've been doing it, which is fine if we didn't, because you still would multiply 5 times 6, which makes 30, and you still would have multiplied 7.5 times 4. At this point, you want a whiteboard marker. We are going to practice. So you're answering these, you know. You can do them one at a time. If you want to do the first one and show me the answer. Correct. So you would go back and name it AB. That's correct. That's correct. And you're getting there. One of them is a fraction. Leave it like a fraction. Just reduce it. Maybe one of them is not a fraction. Maybe it's the next slide. Correct. Good. When you say length of AB, you don't put a line above it. That's okay. Is that the second one? That's good. Yes, that's good. Bless you. Both are correct. All 4 are correct. 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 Those are, one's correct. I just can't read it upside down. This one, you divided by 3 would divide by 5.
What?
You wrote 3 instead of 5.
Yeah, okay. I'm doing all of them.
That's okay. The last one, what would your fraction look like? What is one way your fraction could look at least? 22 over 5, and it would equal 35.2 over 8. Cross multiply, you get 168? 176, maybe. 176 equals 176, so then these are parallel. You would say QR is parallel to ST, which would be these two. Perfect. Some other review from previous sections. You're going to find the value of x. The triangles are similar. Find the value of x. One of them is a fraction. I would leave it like a fraction. So up and down need to correspond, and across need to be from the same shape. The first one is fraction form because there's no decimals. The second one really is a decimal. That's because you're checking it exactly right. Exactly. So up and down need to correspond. So these correspond, but straight across need to be from the same shape. So for the first one, I saw a lot of you using 10 and 6 first. If I put 10 in my numerator, what would have to go in my second numerator? It would have to be x. So these two are from the same shape. And then the bottom also have to be from the same shape. In order for you to cross multiply, you would get 70 equals 6x. Divide by 6. You're going to leave it like a fraction. What are 70 and 6 both divisible by? 2. What is 70 divided by 2? 35. And then 6 divided by 2 is 3. That's the first one. The second one, you get a decimal for sure, because you start with a decimal. You should end with a decimal.
I didn't know there was a problem version of this.
There's what?
I never did it. Like solve the problem.
How did you solve the problem?
In the wrong way again.
Okay. That's correct. That's correct. Good. Getting there. There are a couple ways to solve it. I just said a proportions.
That way I kept getting
I
it.
see.
I had to do the calculator.
I see. That's correct. The second one, what did your first fraction look like? There's no right or wrong answer at this first one. X over what? 4.1, so they correspond with each other. What number would have to go in the numerator? 4.2, because it's from the same shape as x, and then 3.9 would go in the denominator. You cross multiply, you get 4.4. 4.4. Solving the proportion. What is the only difference in this problem than what we've been doing? What do we have to make sure that we do? We have to make sure we distribute when we go this way. It's 5 times both x and negative 1. So one of them is a whole number and one of them is a fraction. I'll hand you the study guide as long as when we go back to the whiteboard, you go back. I do go over some of it if you just want to go through like the math. I have a math problem. You just reduce this. These are both equal by number. There you go. So as long as you go back to this one, you go back to this. So, you said it. So for this one, you would multiply by both x and -1. So what is 5 times x? And then 5 times -1? -5. Some people write it out like this before they start working. That's also fine. Cross multiply the other way. 3 times 2x is 6x. Subtract 5x. And x is -5. There you go. Give you a chance to answer the second. These are both visible by number. What?
I need to say.
What? You have to answer the question. And then you gotta redo. Oh, that's easy. That's good. I think you can reduce again. And you can look at it here in a second. Except for you didn't reduce, Kalani. You want to reduce? Oh, it makes -6. So you don't have to resolve it. You just want to do it. And then you'll reduce this fraction. How'd you get 5? You subtracted 18. It's okay. It's a really money work. What's 8 minus 2? Good, and then divide by negatives, and then you're going to reduce. And then there's your answer. Okay. So you cross multiply, you get 12x equals, got to multiply 9 times both 2x and times 3. So that would be 18x plus 27. Subtract 18x, you get -6. X equals 27. Divide by -6. What are 27 and 6 both divisible by? 3. So divide them both by 3. You get 9 over -2. Perfect. Go back to your whiteboard. If you're standard, you can stop this video. If you're honors, we keep going. On your whiteboard. So not a pencil moving, just your whiteboard real quick, this answer. There are 3 theorems that prove triangles are similar. You may use your notes. There are 3 of them. You're going to list them. Correct. So we're going to talk about what they do. One of them is not a thing. Correct. Correct. So you can go to page, great. you can go to page 2 or 3, page 3 of your study guide. We'll talk about each of them. You can write it down as we talk about them. And talk about what has to happen to have each of these theorems. So, is the first one listed angle, angle? Perfect. Angle, angle. We have to have, in similar shapes in general, what do the angles need to be? Congruent. And then what do the sides need to be? Proportional. So for angle, angle, what do the two angles have to be? Congruent. So you need two congruent angles. This is my abbreviated version. If you want to write it out, that's fine. For side, angle, side, where does that angle have to be? In between them, so keep that in mind. So we need two sides. What should the sides be? Two proportional sides. I'm going to put prop, as long as you know what proportional means. And a congruent angle. Congruent angle in between. So two proportional sides and a congruent angle in between. Whereas side, 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 what do we need? Three proportional sides. Those are your three theorems. So we have two more slides and we'll practice, and then we're going to talk about your study guide together. So, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So on your whiteboard, you're going to determine whether the triangles are similar, and then if they are, write a similarity statement and explain your reasoning. Your reasoning should be one of the theorems. Look for one of the theorems you're trying to prove and explain why or why not. Do that. So which of the theorems are you trying to look for in these two pictures? You're trying to look for angle, angle. So when you explain your reasoning, you either tell me it's angle, angle, or you tell me it's not angle, angle. Or there aren't enough angles congruent or something to that effect. So you didn't fully answer the first one. You did not fully answer the first one. You did not fully answer the first one. All right, let's read the directions. Determine whether they are similar. And then what does it say after that? If they are, write a similarity statement. And then explain your reasoning. So if they are similar, you should have three things written. A yes, and then a similarity statement, and then your reasoning. If they are not, you say no, and you explain your reasoning. So on this first one, do we have two angles congruent to two angles? What's the measure of angle C? 75. So do we have two angles congruent to two angles? So yes, they're similar. Then it says write a similarity statement. I haven't seen any of you write one. A similarity statement says triangle blah blah is similar to triangle blah blah. So triangle ABC is similar What would my second triangle be named? I said A, B, C, E, D, F. And then explain your reasoning. Our reasoning is, yeah, angle theorem there. The second, what's the measure of angle A? 34? And this one would be it'd be 106. Am I right? So, are they similar? No. And explain our reasoning. I've seen two different ones and both are acceptable. It's not angle theorem, or the angles aren't congruent. Those are your two options there. Okay? This is the last slide before we talk about your study guide. Determine whether triangles are similar. If they are, write a similarity statement and explain your reasoning. I'm trying to be out of your way, not more in your way. I'm so sorry. That's correct. Good. Did you answer this question, Addison? So pick a side from this first triangle. 10. What does 10 correspond with? I know there's not a statement, but it is the smallest side. So 15. Oop. We want to see if that is equal to. So you'd go back to the original triangle. We could say 14. What does 14 correspond with on the second? 21. And then we want to see if 18 over 27 is proportional. What do each of these reduce down to? 2/3. So are they proportional? Yes, because 2/3 equals 2/3 equals, So you would say, if they are, write a similarity statement and explain your reasoning. So our reasoning is side, right? The sides are proportional. And then what would our similarity statement look like? Yeah, E, G, F is M, L, N. Yep. Good. All right, so go to the first page on your study guide. I could talk to you about where to find things to be helpful to you. I'm going to tell you pages 1 and 2 are from 8.1 only. 1 and 2 are from 8.1. Similar polygons have to have two things, and you wrote it on the first page of 8.1. What are the two things that similar polygons have? Yes, concurrent angles and proportional sides. If you want to figure out if these are similar, you have to have congruent angles and proportional sides. Just finding a scale factor, we've done this before. Using the left to write a statement of proportionality. This is on page 2. Let's all take a look at what a statement of proportionality looked like on page 2. Are we going to use the numbers or the letters for a statement of proportionality? On page 2. You use the letters. How many sides are there? There are 4, so you can have 4 fractions. So that's what it looked like. So make sure to answer accordingly. So letters only. The bottom, I hope that you would be comfortable with. It says find the value of x that makes them similar. X is a side. So what do you know about similar sides? They're proportional. Good. Page 2 is about perimeter and area. This is from page 5, 6, and 7, I think. 5, 6, and 7. And then the next page is from 8.2 and 3. We kind of just reviewed that. And then go to the last page. I just want to point this out to you because a lot of people get this one wrong because they don't necessarily read. It says, determine whether triangle ABC, which is this one, or triangle DEF is similar to XYZ. So which one is going to be in our answer no matter what? XYZ. So in the end, triangle XYZ is similar to another triangle. Just make sure. A lot of people just look at the first one and don't look at they look at the wrong combination. So there's that. Everything else is pretty self-explanatory.